All right, today we're going to dive into something that's absolutely critical to our daily lives, but most of us never really see it. What actually happens to our water after we use it? Let's get into it.
It's a question we probably don't think about much. But the answer? Well, it involves this incredible journey of engineering and biology. That water doesn't just vanish. It's heading off on an adventure to get cleaned and put back into the environment.
So, to really get a handle on this, we're going to follow a single drop of water. We'll trace its path from the moment it goes down the drain all the way through a modern treatment plant until it's ready to rejoin the world. And lucky for us, we've got an expert guide.
Our guide for this trip is a company called Pro Equipment Incorporated, or PEI for short. They're the ones who actually build the machines that make this whole amazing process work. So who better to show us around, right?
Yeah, these guys are not new to the game. They've been deep in the wastewater world since 1997. They started out as a focused company and have just grown into this huge international partnership, always creating new things based on what customers and our planet actually need.
And their expertise is just wow. We're talking more than 40 different product lines. That means they have a tool for pretty much every single step of the treatment journey, from the moment the water arrives till the moment it leaves.
And the scale here, it's just massive. As the headquarters of an international partnership, PEI is part of a business that helps generate over $50 million in sales every year. This is no small-time shop. It's a full-on global mission to keep water clean.
Okay, so here we go. Our drop of water finally makes it to the plant. First stop, the headworks. You can think of this place like the bouncer at the front door of a club, and believe me, it has a really tough job.
So what's the first major hurdle? Getting all the physical stuff out. And I mean everything. People flush, rags, plastics, wipes, you name it. Even rocks and sand that wash in from the streets. All of that has to go before any of the real, detailed cleaning can start.
So how do you do it? With some seriously heavy-duty screens. Take a look at this one, the ProGuard SCC belt screen. It's basically a giant self-cleaning strainer for the whole city, catching all that debris while letting the water pass through.
And it's not just one screen and you're done. No way. You've got a whole lineup of different types. There are these big, burly bar screens for the really large objects, and then others to catch the finer particles. And this part is absolutely crucial, because getting this right protects all the more sensitive, expensive equipment that comes later from getting totally wrecked.
Okay, so we've filtered out all the big junk. Our drop of water is moving on. But now it's facing a whole new kind of challenge, the pollutants that you can't even see.
Right. So how do you clean what you can't screen? This is where it gets really cool. You use biology. See, the water is already filled with these tiny good guy bacteria that naturally love to eat up waste. The trick is to give them a massive boost by pumping the water full of oxygen. It's a process called aeration.
And there are basically two main ways they do this. You've got diffusers, which work from the bottom up. They release millions of tiny little air bubbles that float up through the water. It's a super energy efficient method. Then you have surface aerators. They're usually cheaper and simpler, and they do the exact opposite. They violently churn and spray the water up into the air to mix it with oxygen.
And here's what they actually look like in action. On the left, you can see those fine bubble diffusers creating what looks like a curtain of oxygen. And on the right, that high-speed surface aerator is creating a powerful spray. So you've got two very different methods, but they share the exact same goal. Get as much oxygen into that water as possible for our hungry little bacteria to do their job.
Okay, the water is getting a lot cleaner, but all that screening and all that biological activity has created a new challenge. It's a sludgy, semi-solid byproduct. So what in the world do you do with all of these leftovers?
It all comes down to a three-step process. First up is separation. You just let the solid stuff settle to the bottom. Step 2 is thickening, where you start removing water to make the sludge more concentrated. And finally, dewatering, where you literally press out the remaining water until you have a dry, crumbly material they call a cake.
Now for that first step, separation, they often use a really clever device like this, a ProPlate lamella clarifier. Instead of needing a giant space-hogging tank for things to settle, this thing uses a whole series of angled plates. It creates a massive amount of settling surface in a much smaller space, making the whole process way faster.
And for those last two steps, you bring in the heavy machinery.
On the left, you've got a rotary drum thickener that tumbles the sludge to help separate out more water. Then, on the right, you have a belt press, and it does exactly what it sounds like. It squeezes that thickened sludge between two powerful belts, literally pressing out as much water as possible.
But here's what's really fascinating to me. This powerful, rugged technology. It isn't just for cleaning up wastewater. The very same equipment and principles are used in a ton of other industries. Now really think about it for a second. The mixers that blend sludge can also homogenize liquids in a chemical plant. The pumps that move wastewater around are also used in food processing. The tough-as-nails conveyors that handle grit are perfect for mining, and those high-tech filters are critical for making paper. The ideas are just incredibly versatile.
So when you take a step back and zoom out, you realize this isn't just a local issue. Clean water is a global challenge. And the technology that gets us there, well, it has a truly worldwide impact. And that's perfectly mirrored in PEI's own business. They're the headquarters of an international partnership, so their know-how and their technology reach across the entire globe, with partners and factories in Europe and Asia, all of them working on the same fundamental problems. Which really just brings us to this one final massive question. When you see the sheer scale of it all, how on earth do you even begin to tackle a problem as big as treating a whole world's worth of water? Well, the answer is both incredibly simple and pretty profound. You do it the way PIE says they do. One drop at a time. It's a great reminder, isn't it, that all the biggest, most overwhelming challenges are solved by focusing on the details, by innovating relentlessly, and by never forgetting the journey of that one single drop. Thanks for joining me for this explainer.